Hi folks, in this video we get some more practice with doing formal proofs and quantifiers. So pause your videos and see if you can complete this formal proof. Okay, this sentence is a first order validity because we have no premises up here. We have to just make some temporary assumptions in order to prove this. Hopefully you notice that this sentence is a wide scope negation. So what you ought to do is plan out a reductio. Let's assume the opposite of the conclusion and then see if we can prove a contradiction. Now, that might not tell you too much about what you should be doing next, but at least the thing that I think is helpful to keep in mind is anytime you start a reductio, first to fill in the symbol that you need down here, the contradiction symbol. That's your new goal. You're not trying to get to this final conclusion anymore. You're just trying to prove a contradiction. So keep your eyes out for how you could possibly derive a contradiction. Now, what we need to do next is look at the main connective of our premise. This is the only thing that we have to go on. Luckily, this is a universal quantifier, and we know what to do with universal quantifiers. We have to instantiate this thing. You might have thought, well, wait a minute, there's no other names in this proof, so it's not apparent to me whether I should instantiate this for A or B or E or N. What am I supposed to instantiate this for? Your first reaction might be N, because oftentimes when there's not a name already appearing in a proof, we end up using N. Maybe you even wanted to write at N and declare an arbitrary constant, but that would have been the wrong plan. Now, why is that? Because you only write at N, declare that N is some arbitrary object in the domain for two reasons, and neither of those is relevant here. Reason number one is because you have an existential sentence and you're doing existential elim. That requires an arbitrary name, but this is not that case. This is not an existential premise. Or you might have a universal conclusion and you're declaring an arbitrary name in order to prove something completely general about any object in the domain. So you can do universal intro. But this is not a universal conclusion, remember. We're not doing universal intro to get this because we can't possibly do universal intro to get this because this is not a universal. It's a negation. Remember, it's all about the main connectives. So don't be fooled by seeing this universal quantifier down here. So there is no reason to be declaring an arbitrary name N anywhere in this proof. Now, when it's still not apparent to you which name you should choose, then just start with A. That's the simplest thing to do. Of course, from a logical point of view, any name would be adequate here. You just have to get rid of that variable to start talking about some object in particular, but it shouldn't be an arbitrary one. So once we have A, now we can see there's a contradiction latent in here because I have P of A and I have not P of A. Clearly, those two things contradict each other. Your job is just to make it apparent, to show how the contradiction symbol comes about from those things. If this were a wide scope conjunction, it would be super easy. You would just do conjunction elim twice. But how are we going to use this disjunction? It takes a little bit of creativity to realize that all you need to do is assume one side of it. It doesn't matter which side you pick. I'll just start with the left-hand side. What if P of A were the case? Well, P of A can't possibly be the case because this says if P of A is the case, if and only if not P of A is the case. So if I assumed P of A, I could just do biconditional elim to get not P of A. That is a contradiction. So now I've got my contradiction between those two literals, and that allows me to do a reductio. I can show that P of A cannot possibly be the case. Instead, not P of A has to be true by negation intro. But wait a minute, since this is a biconditional, it goes in the other direction. Since not P of A is true, I can then infer P of A by biconditional elim. And that, of course, is how I get my final contradiction. So this sentence really is that when I'm talking about A, this is a tautological contradiction. Or to put a quantifier around it, wide scope around it, this is a first order contradiction. That's why I can prove a contradiction with no other premises, just from first order logic from that assumption, which is a way of saying this thing with the negation wide scope is really a first order validity. The rules of logic alone can prove to you that this thing is not possibly true. So negation intro finishes off the proof. Okay.